Very. So only 2 points, then
Yes, sir.
we close. Okay. So here it is. It's a comparison of OSI and TCP IP model. And also we'll discuss OSI model respect of troubleshooting related, at least some basic troubleshooting points. We have a very hard time, like only 15 minutes, 20 minutes time. So within 20 minutes, there is a model called a DoD model, Department of Defense. Okay, Department of Defense model is there. Usually, all these computers, network, all these things are started from the military strategies only, defense related kind of stuff from their researches only. These are all outcomes. Later, it is divided into a separate subject. Okay, computer, IT related subjects, networking, like that. It is divided. So here it is all are different subjects. Okay, this is a called a DoD model. Okay, don't get confused. There is a DOS also there. In DOS also there is confusion something. So this is DoD, Department of Defense model. This is later named it as a TCP IP protocol suite, a TCP IP model. Transmission control, internet protocol. IP means internet protocol, because in TCP IP we are using IP addresses. Logical address is IP address use. Okay, IPv4 or IPv6 we are using. So TCP IP model. So DoD model, later it is become TCP IP model. So what are the layers in this model? Only 4 layers: application, transport, internet, network, access layer. Application, transport, internet, network, access layer. Some people think OSI and TCP IP differences. It's not differences, it's just a comparison. Okay. And some people think OSI model having 7 and this having only 4. There's some kind of advantage, disadvantages are there. No, guys, because OSI is, we already know it is a reference model. Okay, it is, this model is applicable for all the type of network models. The TCP IP is one kind of model which we are using. In TCP IP, 4 layers: application, transport, internet, network access layer. In TCP IP, application layer, that one application layer will perform all the task of application, presentation, session layered works in the OSI model, in a OSI model. Means one application layer in TCP IP. TCP IP application layer is equivalent to application, presentation, session. All these things will do it. Okay. So your open browser application, you are sending and receiving data. So your application layer one time only, it will convert into data. Sessions will be created there only. This tab, one session. This is one session. Okay. Like that. So session. Next. Transport layer and transport layer in the both OS and TCP, same to same. Same to same. Segmenting the data, add a segmented data to segment number and window size, TCP and UDP, protocols, port number, TCP source and destination port number, UDP source and destination port numbers are added. Means your protocols port numbers are added. So that is totally, we call it as segment. So we chop the data into the into multiple segments. So then a transport layer total data is become multiple segments. Multiple segments. So it is same in the both voice and in TCP IP internet. Internet layer is similar to the network layer. In network layer, what we are doing is we are adding source IP, destination IP to your segment, one segment. Right? Next, we are adding routing information, means how to send this data, which interface data has to be sent, which way that data has to be sent. Like that, we're adding routing information at network layer. Okay. Next, network access layer. In TCP IP, network access layer. It is will do both jobs. Data link and physical layer, both will be works. Data link and physical layer. So what is a data link will do it? It attaches source MAC address, destination MAC address to your packet from the network layer and added CRC, cyclic redundancy check. This is checksum data to verify at destination data is good or corrupted while it is transmitted. If data is corrupted, drop the packet. Data is good, accept the packet. Okay. So that is data link. This is a total one we call it as frame. That frame again convert into the bit stream based on your physical connectivity. It will convert into that bit stream again convert into that related signal. Okay. If you are using fiber optic based connectivity, light waves. If you are using radio connectivity, means Wi-Fi type of connection, radio signal 2.4 or 5 gigahertz connection. If you are using a Ethernet LAN cable, then it is converted into electrical signal. Okay. So we have a LAN cards, right? In a NIC, LAN cards, Wi-Fi adapters. Okay. These are all comes under in a TCP/IP network access layer because it do both the things, data link layer and physical layer part also it will do it. Okay. In our system, hardware part is these two parts. These are hardware part. This is software layer only. These are all software part. Okay. So these are the TCP/IP and OSI model comparison. Let's understand what is TCP/IP layers and OSI and TCP/IP comparison.
Yes, sir.
Very. Next, troubleshooting using OSI model. So we understand how this OSI model works. So this is troubleshooting using OSI model. Here it is. Any network related issues based on the error message or based on what it is showing, we can understand where is the issue from where we have to start it. So most generalization, most general, you don't get any idea. Then at least start from here. What is it? Physical layer. Means connectivity. Physical layer is about connectivity. Both systems are connected or not. Both source and destination connected or not. If it is through LAN cable connected, is it Wi-Fi? Wi-Fi based connectivity is there, then Wi-Fi is connected or not. Both are connected in the same network, means my source and destination both are in the same floor, same building. Both are connected either directly or indirectly. Means I'm using laptop through Wi-Fi and connected to my Wi-Fi router. So there is a desktop. Okay, there is a desktop. So that desktop is connected to network through LAN cable. So it is connected to the LAN cable and switch. And switch is connected to the router. Router is I connected to the router. Means not directly, but indirectly also we are connected. Source and destination both are connected. So I can able to communicate. So first check the connectivity. Check total connectivity. First initial connectivity and total connectivity from both source and destination. Second check is IP address. I think you understand already in the IP address classes. Okay. So what is the one network and other network? So if two systems need to be communicate each other in the same logical network, same logical and physical network, both systems want to communicate each other, their network ID must be same. Means their network portion must be same or network ID must be same. Right? I think you have seen that network ID calculations and what is network and host portions. In class A, the W is network portion. So in one class A network, the W must be same. In class B, WX means first octet, second octet must be same for entire network. in a class C, first three portions or first three octets are WXY must be same for in entire one single logical network. If network portion is different from two systems means both are in the different networks. Okay. So compulsory check the IP address, both source IP, destination IP. Make sure both are in the same network, means same logical network and similar same physical network. If the remote means the destination is outside of your network, outside of your physical and logical network, means IP address definitely it's different. For example, google.com, facebook.com, youtube.com, outside of your network, they have their different IP addresses. Okay, so that is where IP address seeking. So these are the most commonly very helpful in the troubleshooting. Any two devices are not connecting, check the connectivity, check the IP address, and test the connectivity with a ping command. You can also use ping command to test the connectivity between the devices. Both are able to communicate and like this. Ping. So my remote device IP address, this one. So from my laptop to that remote device, IP address is communicating. Means both are in the same physical and logical network. That's why I can able to come. Reply from destination. Meaning is I am able to send and receive packet to this system from my system. Okay. So check the IP address in both sides and test the connectivity between the devices using ping command. Finally, not finally, transport layer. So we understand transport layer is segmenting data, but in a transport layer also we are using TCP, UDP protocols for their port numbers. Either it is system built-in firewall or any antivirus system installed any antivirus firewall or whole organizational firewall. Okay, or OS level or especially application or entire organization firewalls. When I want to connect, for example, I have a remote server. It is a web server. I want to access its website. So I send a HTTP request. It's a HTTP website only. So I send HTTP request. And that server, it should accept this HTTP request. So first, my remote system, here it is. How this verification happens at the destination. At destination, how this verifications happens. You send a request means you are added source MAC address, destination MAC address, source IP, destination IP. These are to identify this device. Next, in transport layer, you are adding port number, protocol or a port number, TCP type or UDP type, whatever it is. If it is TCP type, it's under TCP port and it is under UDP. If it is, there is a UDP port and missing. What are the UDP port numbers in this communication? What are the TCP port numbers in this communication is also there. So from here we'll see that. So once you reach the destination, you check the what is incoming packet at data link layer. Physical layer, convert your signal into bitstream to frame. In data link layer, you take the frame and check the source MAC address and destination MAC address and your packet and CRC, right? Using CRC, it verifies the data is good or corrupted. If data is corrupted, drop the packet. Data is good, accept the packet. And check the destination MAC address. This destination MAC system, the system's MAC address, interface MAC address, and this MAC address, incoming packet MAC address. Both are same. Then accept the packet. Accept the packet at a data link layer wise. Next, network layer.